My name is Erin Koren. I'm the Director of Education at the Grand Rapids Public Museum. And joining me a little bit later on in the call is Jack Dulesky, who's our planetarium manager. And we're happy to be able to talk with this cohort today, share some resources for climate change education, because we have some relevant things going on at the museum right now. And hopefully it'll be of value to you as you work on developing your curriculum as part of this cohort. So we have a climate change exhibit right now at the museum through April 25th of next year called Under the Arctic, Digging into Permafrost. And it's a pretty awesome exhibit. It was developed by the Oregon Museum of Science and Industry in collaboration with the University of Alaska Fairbanks and an Alaskan Native Advisory Council. So the main feature in the exhibit I put in this photo on the left is a replica of the only permafrost research facility in the Western Hemisphere, which is located in Alaska. And the exhibit really just aims to educate visitors about permafrost and the impact it has on climate change. So permafrost is actually defined as ground that has stayed frozen for at least 2 years. And permafrost is rapidly thawing on Earth. And since it's no longer cold enough on Earth to form new permafrost, most of the permafrost that we have formed during the Ice Age, almost 12,000 years ago. And permafrost is pretty extensive. It covers 20% of land area on Earth and is not just in the Arctic, but there's some in the US as well in the Rocky Mountains. So thawing permafrost is harmful in Arctic communities and across the globe because it holds a lot of frozen plant matter. And as permafrost thaws, that plant matter decays and releases carbon dioxide and methane, heat trapping gases into the atmosphere. So I wanted to show some pictures of the exhibit just to highlight some of the cool features that it has. Like I said, the main event is kind of this permafrost research tunnel that is set up with, fossils and ice structures in the tunnel. There are a lot of hands-on stations that are meant to mimic field labs where you can conduct sample analysis. You can look at fossils under microscope magnifiers. This station on the right here is an atmosphere kind of simulator station showing the heat trapping atmosphere effect on temperature. There's lots of interactive games and competitions in the exhibit, such as one that's pretty creative, which is a whack-a-mole game that is meant to show global fossil fuel reserves. And the game is sort of a whack-a-mole to keep fossil fuels in the ground. And then just lastly, there's a section, Northern Stories Theater, they call it, that it has Alaskan Native villagers sharing how permafrost thaw and climate change are impacting their communities. And throughout the exhibit, there are stations with takeaways on actions and community efforts to combat climate change. And before I move on, I wanted to point out that their big message really is that rather than targeting individual actions, they want visitors to come away with an understanding of larger systemic solutions to climate change. They really promote local, national, international collaboration to transition our energy economy to renewable energy sources. The exhibit came with an educator guide that is a wonderful resource for teachers like yourselves looking to talk about climate change with learners, looking to develop activities and curriculum related to the topic. So I wanted to give an overview of some really helpful sections in this guide. First of all, it's got a nice, easy to reference glossary of some key terms. It's got a section that's quite extensive on frequently asked questions and answers in talking about climate change, specifically in talking about climate change maybe with parents or students who are skeptical. And they have a section on tips for productive climate change conversations, how to facilitate those. I would encourage you, I'm going to just cover some of the tips really briefly that they recommend for having climate change conversations, but I would encourage you maybe in the chat right now or in our conversation time later to think about strategies you found useful or that seem that they might be more useful than what's recommended here. So the guide really suggests in talking about climate change to use a reasonable tone. And that's kind of a loaded word, I think. But what they mean by that is use kind of matter-of-fact, optimistic language when talking about climate change. They recommend appealing to widely shared values. And a lot of this educator guide they put together is based on best practices and research and 2 widely shared values that they feel can be impactful in addressing the root causes of climate change and can be impactful in drawing people into the conversation are protection of people and places and responsible management, playing into the idea of managing our resources for future generations. Something I'm interested to see in the chat or our conversation later is if anybody has explanatory metaphors, what the educator guide calls, that they use to share about climate change. This guide recommends, talking about carbon dioxide and methane gas as a metaphor of a heat trapping blanket around the earth, or they use a really interesting metaphor to answer the question of if people are concerned about the expenses that might come with moving from coal and fossil fuel to renewable energy sources. And the guide recommends comparing that to like a junk food diet versus a healthier, nutritious diet. It might be cheaper to purchase initially, but that's not factoring in the longer term health consequences of healthcare that might come if you're only having a diet of junk food. And then they just suggest a focus on hope and civic action. Kind of what I mentioned before, they recommend educators highlight systemic initiatives that address climate change, even pulling in local initiatives when they're relevant. Moving on, I wanted to do this brief slide to just reference that there's a really helpful section of this guide, an activity guide for educators, not just based on coming to visit the exhibit, but resources for the classroom, virtual learning, or in-person learning. So I wanted to quickly share this video just to show that some of these activities, like this one, which they call Metabolizing Microbes, can come together with cheap materials. They provide a script, a facilitation guide on how to do these activities. So I did a quick example the other day that I wanted to share with you here.
In this demonstration, called Metabolizing Microbes, I've put equal amounts of yeast, sugar, and water into each bottle. The only difference is the temperature of the water. Can you guess which yeast I put in warm water and which I put in ice cold water? You're probably right. In this bottle, I put hot water. In this, I put ice cold water. I'm using this demonstration to show what happens when permafrost thaws. Frozen in permafrost are the remains of ice age plants and animals. This is great food for microbes, so imagine that the sugar I've put in each bottle represents the organic material in permafrost. With cold water, you can see what happens when permafrost stays frozen. The microbes stay dormant and never eat the food. With warm water, though, they wake up. Can anyone guess what's in the balloon? It's actually carbon dioxide. And this is good when you're baking with yeast and sugar. It releases gas bubbles, and this is what makes your bread or baking get yummy and fluffy. It makes it rise. However, the same process is why climate scientists are concerned about permafrost thaw, because when it thaws, microbes can release carbon dioxide and methane. And these are heat-trapping gases, the same ones we release when we burn fossil fuels. When they enter the atmosphere, they act like a blanket around the Earth, trapping heat and warming our planet. The more our planet warms, the more permafrost thaws due to climate change, releasing carbon dioxide into the atmosphere. And the more permafrost thaws, the more it releases heat-trapping gases into the air, which causes even more warming. This is called a feedback loop.
All right, so I just wanted to close. I know I had a real just brief amount of time, but I thought it would be useful to share the educator guide with you as you embark on your own curriculum development. I always find that it's great to just collect those resources, pieces of inspiration that you can find pieces maybe to pull into what you develop or pull into your own practice. And I wanted to share my email and encourage, Amanda and Janet, whoever is give permission to share my email with this group, because I'm always open to, if you'd like to reach out, get more information, think about if there's any museum partnership that might benefit you, or further resources we might be able to direct you to. And this I just put up here as an example. For the last several years, we've run an after school program with middle school age students, some local school districts, all about renewable energy, and having this group of students think about designing solutions in our communities for more sustainable energy options. We've done a lot of hands-on experiment and programming with like modular solar panels and wind turbines and things like that. I just had a brief amount of time, but I wanted to mention the exhibit, the Educator resource guide, and just the fact that I've run this type of renewable energy programming as well, and would be happy if anybody has any questions about that.